For lesson 1-3, we're talking about variables and expressions. And during this lesson, you'll be able to translate verbal phrases into algebraic expressions. And you'll also be able to evaluate expressions containing variables. Remember to keep your focus on the essential question for Chapter 1, which is how can you use numbers and symbols to represent mathematical ideas? There are a few more vocabulary words for this lesson. Just make sure you get down the definitions, either using your glossary or your textbook right here. It gives you the definitions right here. Algebra is a branch of mathematics that uses symbols. And then a variable is a letter or symbol used to represent an unknown value. Last section we looked at numerical expressions, and now we're going to take a look at algebraic expressions. Algebraic expressions have at least one variable and then one mathematical operation, sometimes more. And then when we're translating phrases into mathematical sentences, we have to often define a variable. We're going to say that x is going to be equal to something, or we can say z is equal to something. Okay, so we're going to be using those skills and those vocabulary words as we work through this lesson. Okay, so we have words which we're used to when we read books or we read papers or magazine articles. We read the words on the page, but in algebra we're going to translate that into expressions using a variable and then coming down to numbers, variables, and operations. So we're going to be working through a few examples here together. On page 14, we have example 1. Make sure you read through these lessons, examples, and you can also refer to the video tutors that are part of your online textbook. I'm going to jump down here to the Got It section. Remember that you can pause the video and try to work those out on your own and then hit play to see how you did. You can also follow along with me and just do those problems right on your note sheet. So here we are on your note sheet, variables and expressions, lesson 1-3, your 2 I can statements, and then your vocabulary words. We're going to look through a couple of problems that I'd like for you to work out here in these boxes down here. And you can also take notes on any other problems that you have that you want to work out with me when we meet face to face. Don't forget that you always have a self-check quiz to take. Those are 5 questions to make sure that you understand the gist of the lesson, and then always send a screenshot to me so I can mark that down as completed. So for your note sheet, we're going to look through 1A and B. 2 miles less than the athlete ran. Well, in this, we don't know how much the athlete ran, so I'm going to define a variable. I can use the letter A, I can use the letter X, I can use whatever letter I want. There are some letters that we typically stay away from in algebra, like the letter L looks like the number 1, and other like O can look like the 0. So we do kind of stay away from some letters, but in this case, we're going to say the athlete ran A miles because we don't know that. And then 2 miles less than that would be minus 2, okay? Now, some students might think less than is this symbol right here, and you are absolutely right, that is a less than symbol. But in this case, we're writing algebraic expressions, and algebraic expressions have operations: addition, subtraction, multiplication, and division. If I asked you to write an inequality, that's when you'd start using these symbols here that you might be thinking of. But in this case, 2 miles less than the athlete ran is A minus 2. And then 1B, 5 points more than the points scored by field goals if each field goal is worth 3 points. There's a lot of words there, but what we want to do first is find the unknown. We don't know how many field goals were scored, so we're just going to write the variable, define the variable f for field goals. Now, if we knew the number of field goals, we would take the number of field goals times 3 because each field goal is worth 3 points. You could write that 3 parentheses f, or you could write down that 3 dot f, or you could just write down 3f. 3f means 3 times f. Okay, and then 5 more points than that, we would just do a plus 5. Now you might be thinking, does it matter if it's 3f plus 5 or 5 plus 3f. Either one is correct. Typically, when you're writing algebraic expressions, the variables come first, and so 3f plus 5 would probably be more commonly seen than 5 plus 3f, but both are correct because the commutative property, which we'll get to later in this chapter, means that it doesn't matter whether it's 5 plus 3f or 3f plus 5, you're going to get the same answer. Okay, so make sure you understand those two, and let's jump down here to another vocabulary word. Okay, the substitution property of equality means that when you replace the variable with a number, you are using the substitution property. Again, there's a video that you can reference if you need help with that and you want to work through a few more examples. But all we're doing is we're plugging in numbers for the value or for the variable, and then we're evaluating it. So if E is 3, 6 minus 3 plus f, we're going to substitute that 9 in for f here, and we have 6 minus 3, which is 3. 3 plus 9 is equal to 12. For 2b, we're going to substitute that 4 in for k and that 10 in for h. So we have 7 times k, which is 7 times 4, which is 28. And then 28 plus 10 is equal to 38. Okay, make sure you have those on your note sheet and the answers there. We are also going to take a look this time. Going back here, got it, 3B, A, B, and C. We're going to do a few more from the book, and then I'll do a few on your homework assignment. So going ahead to page 15, let's look at 3. On 3, we have, again, a video tutor if you want to check that out for more examples, okay? And then read through A, B, and C. A, B, and C on example 3 are involving multiplication and division here. So we have a few more variables. A is equal to 4. My process here is I usually cross off the variables and put in the numbers. And C is equal to 12. I like to show my work. 3 times 4 is 12. And then 2 times 12 is 24. And then 12 plus 24 gives me my final answer of 36. Okay, so it kind of looks like a funnel in the end. It starts out large and it boils down to that last simplified answer, 36. AB means A times B, or in this case, 4 times 8, not 48, but 4 times 8 is 32. And then 32 divided by 16, we can simplify that further to equal 2. Okay? Sometimes you'll see the word evaluate, and sometimes you'll see the word simplify. We usually simplify numerical expressions when there's just numbers and operations, and then we evaluate when we have variables. So you'll see both of those words pretty often. In 3C, we have C equals 12. 5B is 5 times 8, which is 40. And then 2 times A, 2 times 4 is equal to 8. So 40 minus 8 is 32. And then 32 plus 12 is equal to 43. Let me just double check my work by pressing the on button here with my answers, and I see that I made a mistake here. 12 plus 32 is not 43, it's 44. So I still make those very careless mistakes by not checking my work and rushing through, so make sure you do the same. The last thing I'm going to do for this lesson is to take a look at your skills practice worksheet. You're doing all of these problems here for homework, and it's just not to give you a bunch of homework, but for really you to practice the skill of translating phrases into expressions. So I'll do a few of these problems with you. For number 1, 2 inches shorter than Catherine's height. We don't know what Catherine's height is, so we'll just define the variable k. And 2 inches shorter than that would be Catherine's height minus 2. So very simple. I'll jump down to number 6. The difference of some number and 18. Okay, if I was going to say what's the difference between my age and 18, it would be my age, 42, minus 18. But in this case, it says the difference of some number. Well, we don't know what that number is, so we're going to define a variable. Let's just say that that variable is x. We don't know the age, so we're just going to cross that off and we're going to put a variable instead, and then we're going to find the difference between that number and 18. So the answer to number 6 is x minus 18. And number 10, twice as long as the length of the string. Well, we don't know the length of the string, so we're going to say s for string. Sometimes s is not a good variable to use because it looks like the number 5, but in this case, we'll go ahead and use s for string, and then twice as long, we could write that as 2s. We could also write that as 2 dot s. We could also write that as 2 asterisk s. All of those would be acceptable ways to write down that phrase into expression. And let's see here, let's do number 18. Y times z. Well, y is 6 and z is 3. So y times z would be 6 times 3, which is 18. 18 minus x, which is 4. 18 minus 4 is equal to 14. And finally, at the bottom here, let's do a couple of these. 22, 3 times a. 3 times 7 is 21. 4 times d, 4 times 5 is 20. And 21 plus 20 is equal to 41. Let's do 29. BC means b times c. So that's 9 times 2, and not 92, but 9 times 2. 9 times 2 is equal to 18. In the denominator, a minus d, 7 minus 5. 7 minus 5 is equal to 2, and 18 divided by 2 is equal to 9. Hopefully that gets you started on your homework for lesson 1-3. Good luck, and let me know if you have any questions on any of those problems.